Okay, good evening, everyone. Today we are going to discuss practice paper 15. In this paper, we are going to discuss a set of bonding lesson questions. It's better to add these reviews to your theory book. Okay, so like you can see here, this first question I selected today is coming from the bonding, the page number 28. Understand? So it's better to write the review and attach that one or paste that one in your theory book. Okay, so let's start the first one. They have given us a molecule. So first of all, you might have a doubt regarding what is this hexagon structure. Okay, so what is this structure? What is this hexagon structure? So this hexagon structure is called as benzene. I did a small explanation about this one in our earlier theory class. Okay, so this is benzene. Benzene is a molecule you will learn in organic chemistry. Organic chemistry is the unit 7, 8, 9, 10. You have 14 units in chemistry. So 7, 8, 9, 10 are the organic chemistry units. And for A-level exam, you will be having around 25 marks from this single organic topic. Okay, so it's a very important one, and kind of there are no calculations attached to that. And there is a little bit things to memorize also. It kind of depends on your critical thinking. So once you do the lesson, you will understand. And anyway, you are seeing this molecule in the benzene in this organic chemistry, right? So benzene, even though you draw it like this, it is actually composed of carbon and hydrogen. You have 6 carbon atoms and 6 hydrogen atoms there. Okay, so but in this structure, you are not seeing the carbon or hydrogen. So I'm going to show you how exactly they are connected. So even though we draw it like this, actually the benzene molecule is something like this. You have 6 carbon atoms arranged in a ring. Okay, and for each carbon atom, you have a hydrogen. You have a hydrogen atom. Okay, and then in these places they have marked with dashes, you have double bonds. Because carbon must make 4 bonds in order to complete the octet. So this is the molecule. This is the molecule. This is what we call as benzene. So this structure is a simplified version. Okay, this is the simplified structure of benzene. Understood? Then once you see this structure, you will understand one important thing. Okay, so your benzene has another structure. Okay, so tell me the name we give for this additional structure. Actually, these two are what? What's the name we can give? Yes, we can say these two are the resonance structures. Resonance structures of benzene. Resonance structures of benzene. Understand? So your real benzene is what now? So real benzene or the actual benzene molecule is a resonance hybrid of these two structures. Resonance hybrid of these two structures. Understand, Lama? So actual benzene is a hybrid of these two. That means you can kind of try to represent that one, but this is not going to 100% accurate. But anyway, you can try. Okay, so that means you have partial 5 bonds. Remember, you have partial 5 bonds. Until we learn benzene for organic chemistry, let's stick to this diagram. Okay, you will understand much more details about benzene later. But for now, for the bonding lesson sake, this is in. Okay, so what you have is the bond order. Remember this one? Bond order will be 1.5. Benzene is a resonance hybrid of these two structures. That's what you need to know. Okay, now let's come to the question. Right, now another thing, this is also important. Now your the carbon atom labeled as A is belong to the benzene. It's kind of they have labeled this particular atom. Okay, this particular atom. Right, and this hydrogen is replaced by the carbon. That's the difference, okay? Right, so anyway, what are the hybridizations of these carbon atoms? That's we need before trying the statements. Okay, so what are the hybridizations? So let's start from that then. So you can see this carbon, it is bonded to 4 other atoms, 3 hydrogen atoms and 1 carbon atom. Okay, so this carbon, the D labeled as D, is tetrahedral, having tetrahedral electron pair geometry. Then this one is sp3 hybridized. Understand? And the B and C carbons are linear. Okay, only 2 repulsion units are there, so it is linear. So the hybridization is going to be sp. Okay, and your carbon atom labeled as A. Now you can clearly see that one here. No? So you can see it is having 3 repulsion units around there. Double bond we consider as 1 repulsion unit. Understand? So around this A, or the carbon atom labeled as A, you have 3 repulsion units. Therefore, it is a trigonal plane electron pair geometry. And hybridization is going to be sp2. Understand? sp2. So these are the atoms we have given in this. We have been given in this molecule. Understand? Right. And another small thing. Okay. So when we draw the molecule, actually these angles are not going to be in this way. Isn't it? So if it is linear electron pair geometry, angle is going to be approximately 180. Understand? So around this carbon also, angle should be across approximately 180. But in this diagram, it is not represented as 180. Okay, so if you didn't understand this 180 thing, right, then it will be a problem when you are deciding the answers. Okay, so let's draw that one properly. So this is the benzene molecule we have. Okay, so then if this is sp2 hybridized, then bond angle is 120. You can nicely see that bond angle 120 here. Okay, and then you have this carbon, and to this carbon, they all should be in this along this straight line. And the 3 hydrogen atoms, one will be behind the bond, and another 2 will be in front of the bond. These are the bond angles, right? So now we can peacefully go to the question and decide the answers. Okay, students, understood? I hope it is okay with you. If you have any doubts, you can send a message. So I'll explain it briefly. So now look at the first statement. Carbon atoms labeled as A, B, C, and D do not lie in a straight line. So what do you think? That is going to be wrong, no? So you can see in my diagram, the one I prepared later. Okay, so these are the carbon atoms A, B, C, and D. So they all lie in the same straight line. sp hybridized atoms and connected ones. Connected atoms lie in the same straight line. Same straight line. Understand? So they are in the same line. Is that clear? So therefore, this A statement is going to be wrong. Understood? So A is wrong. Right. Now let's go to the second one. Carbon atoms labeled as A, B, and D are sp2, sp, and sp3 hybridized. So is that true? A is sp2, that is correct. B hybridization is sp. Okay, that is also correct. And the last atom is sp3. Yes. B is correct according to the hybridizations we took. Okay. And look at C. All carbon-carbon bond lengths of benzene ring are equal to each other and are longer than CC triple bond. So what do you think? All carbon atoms in benzene are equal. So that part is correct. You can see all carbon atoms of benzene are actually equal because of this hybrid theory. Understand? Real benzene is a hybrid of these two. No? If you just look at the one structure, you will see that there is a double bond and there is a single bond. So then you might think bond lengths are not equal. Understand? But that is not true, isn't it? None of these structures are existing actually. Okay, both of these structures are contributing 50% each to generate this real structure. Understand? So in the real structure, you will have partial phi bonds because both the places are contributed. So for this particular place, okay, the being this structure, the single bond is contributed and the other structure double bond is contributed. So that's why you have 1.5 bond order here. Understood? So every place you have 1.5 bond order. So bond length of benzene are equal. That is correct. Okay, but look at the second part. It is comparing the bond length of the benzene with the triple bond. So what do you think? Okay, triple bond length is shorter because when the number of bonds are more, actually the triple bond is made by overlapping of sp orbitals. Sp orbitals are short, no? Remember, I'm not going to draw them, just telling you have to understand. Sp orbitals are short, sp3 orbitals are longer. Remember, okay? So these sp orbitals, the short orbitals, will give you a short bond length. Understood? Short bond length. Therefore, your triple bond is shorter than the benzene bonds because benzene you have 1.5. Even this benzene bond lengths are longer than double bond or triple bond. Understood? Okay, and it is shorter than single. That's what you need to understand. Okay, so this benzene, this one, bond length, if you arrange them in order, you can say the triple bond, then the double bond, then you have benzene partial phi bond. Understood? So I write it properly in somewhere we have space. So you can say the triple bond is shorter, then you have the double bond, then you have the benzene bond structure, okay? Then you have the single bond. So this is the order. Understood? So benzene lie right here. Okay, now based on this statement, you can decide whether that is correct. Go to the statement. All carbon-carbon bond lengths in benzene are equal. I said that part is true, but look at the last part. Okay, and are longer than CC triple bond. That is correct. C is correct. C is correct. But look at D. All carbon-carbon bond lengths of benzene are equal and are shorter. So that last statement is wrong. Understand? So your B and C statements are correct. Answer is answer 2. If B and C correct, we select the answer as answer 2. For the B and C statements as the explanation, you can add that order I gave you. Understood, Lama? I hope it is 100% clear. So this is about same line, same straight line. So what can you say about same plane? Just say same plane, same plane. If you have same plane atoms, what should be the condition? We said here, if it is sp hybridized, they belong to them and their connected atoms are belongs to the same straight line. Okay, so what if you want to take same plane? What is the requirement? If you want to take the same plane, the requirement is, you can write it down. It should be sp or sp2 hybridized atoms and they are connected atoms. Okay, I'll tell again. sp2 hybridized atoms. There are two options. Either sp hybridized or sp2 hybridized, and they are connected atoms. Okay, and they are connected atoms. You can see here, all benzene carbon atoms are sp hybridized, sp2 hybridized, no? So all the atoms of benzene will be what? Are in the same plane. That is the requirement. Okay, students? So write a good review for that one. Right. Now shall we go to the next question? And another important theory we discussed in our previous theory class is electronegativity variation. Electronegativity variation of a given element. So if I simply remind you, right? In Pauling scale, it assigns specific or constant numbers for electronegativity. But actually, electronegativity is not a constant number like that. So if you go to the definition of electronegativity, you will understand that one. Electronegativity is the ability to attract electrons. Ability to attract electrons in a bond toward itself. So that ability is not going to be constant because a given element will form various type of bonds. Take for an example nitrogen. So it will make various type of bonds with various other elements. So that attracting ability is not going to be the same. It's a simple logic. So telling electronegativity as a constant value in the Pauling scale is it is not going to be the 100% correct. So electronegativity of a given element is little bit changing. So that is what we learned in last week. Okay. So the factors that affect such changes. Okay. So there are 4 factors. What are those? We represent them by scope, as percentage, charge, oxidation number, and peripheral atom electronegativity. Those are the 4 factors affecting. And in the theory class, I explained why we consider them in that order. Right? You can go through your theory note, and it is nicely explained there. Okay. Right, now let's do a question to revise that theories. Look at the first one. It is from 2023 A-level paper. So I'll put the molecules in the board. Meanwhile, you can send your answer. What is the answer for the second question? Right, now, if you look at the molecules, now we have to properly arrange them in order to see. So here bromine is attached to this carbon atom. And here you have a double bond. Here you have a double bond between 2 carbon atoms. And fluorine is one of the atoms attached. In this molecule also, you have a similar double bond. And you have a chlorine atom instead of fluorine. This one, you have a triple bond between 2 carbon atoms. And fluorine is bonded to one of those triple bonded carbon. Okay. So now what? These are the atoms they are asking for the electronegativity. You can circle them. So the first factor you have to assess is for the electronegativity variation is S percentage. So it depends on the hybridization. So if you take the hybridization here, this is going to be sp3, sp2, sp2 and sp. These are the hybridizations. sp3, sp2, sp2 and sp. Okay. So S percentage is going to be here, one of the 4 orbitals participated for the hybridization is S. So 1/4 is S, no? So therefore, S percentage is 25%. Here, the S percentage is 33.3%. And this molecule also has a similar S percentage because there is also sp2. Here, the S percentage is 50. So what we discussed earlier, if the S percentage is higher, the ability to attract electrons is more. That means electronegativity is more. Okay, because S percentage basically gives you the idea about the bond length. If the bond length is short, ability to attract electrons is higher. Okay, so therefore, the shortest bond length is therefore the sp. So this will be the most electronegative. So if you give rankings, this will be number 1. And then we know number 4, the last one, or the least electronegative atom is our sp3 carbon. So then you have a doubt between whether it is these 2 carbon atoms. Understand? So then in our principle, first one is S percentage, then we have charge, oxidation number, and peripheral atom electronegativity. So like that, we have 4 things to consider. Okay, so if you check for the charge, it is not having any charge. Understand? It is not having any charge. Charge is 0. Now you have to consider other factors for only for these 2 molecules. Okay, so charge is 0. Then if you check for the oxidation number, remember how did we get the oxidation number? By marking dipole moments. If you take the oxidation numbers here, they are both oxidation numbers are 0 because carbon loses 1 electron partially and gains 1 electron partially. So you can see now oxidation numbers are also similar. Then we have to go to the last factor. which is peripheral atom electronegativity. So here the peripheral atom is fluorine and it is more electronegative. If the peripheral atom is more electronegative, our central atom, our carbon, is also going to be more electronegative. Understand? So therefore, our second most electronegative atom is this one, this carbon. And then we have the third one. Understood? That's how answer 4 is coming. Okay, Lama. So there are very few questions that they check up to the peripheral atom electronegativity. There are very few questions. Okay. So mostly they are stopping around the S percentage or charge or oxidation number, somewhere like that. Okay. So therefore, studying this question is a better thing. Okay. So remember, if the peripheral atom is more electronegative, then our central atom is also going to be more electronegative. Right? And you are going to check the peripheral atom electronegativity as the last option, because you are trying to get a difference between them by checking S percentage, charge, and oxidation number and everything. If they all are same, then you are going for the peripheral atom electronegativity. So third question is a similar one, which is from electronegativity. So how do we get the answer? First of all, let's start with the structure. So if you're missing the answer here, if you can't get the answer here, maybe the problem is with your Lewis structures. Let's find it out. So this is structure H2CO. This is how you are going to draw it. It's a special molecule. Again, you will learn that one in organic chemistry. Okay. So this molecule is called formaldehyde. Formaldehyde or methanol. Methanol. Okay. Then you have HCN and NCO. These are the Lewis structures. Okay, so these are the Lewis structures. So first of all, let's check the S percentage. To check the S percentage, you need the hybridization. So I'll quickly write the hybridizations of each atom. So this is sp3, therefore 25% S character. This is also sp3, therefore that also 25% S character. In this one, you can see sp hybridized. sp2 hybridized. So 33.3 S character. So a little bit more electronegative, no? And this one, these two atoms are sp hybridized. So therefore, 50% S character. So now we have an idea what are going to be the most electronegative. So if you rank them, this is going to be our number 1 and number 2. We don't know which one exactly right now, but this must be the number 1 and number 2. So then this must be the least electronegative. That means 4 or 5. Then we know exactly this is our number 3. Okay, so we are not going to check anything again for this one because we already know the position. Then go for the next one. What is the other one? Charge. If you check for the charge, all these carbon atoms are neutral, so no charge. Then go for the next factor, oxidation number. Oxidation number. So if you mark the dipole moments here, you can see carbon is more electronegative than hydrogen. So it gets 4 electrons partially. So therefore oxidation number is -4. Okay. So if they are getting electrons, we say oxidation number is minus. Right. And here, again 3 electrons it gets partially, but here it loses 1 electron for chlorine. So get 3 partially and lose 1 partially. Ultimate result is getting 2. Okay, so oxidation number is going to be -2. Okay, so if you mark the oxidation numbers, this one is -2 and this one is -4. So now you can see -2 is larger than -4, no? Therefore, this must be the more electronegative one. This is the least electronegative one. Is that clear? You can decide the order using oxidation number. So we are not going to check the oxidation number for this one and look at the other two. You mark the dipole moments here. Nitrogen is more electronegative than carbon. And hydrogen is more electronegative than, carbon is more electronegative than hydrogen. So lose 3 electrons partially and take 1 electron partially. So ultimate result is losing 2. So its oxidation number is going to be +2. But if you take this carbon, you can now see oxidation number is going to be +4, right? Because nitrogen is attracting electrons, and this carbon loses another electron for oxygen also. Understood? So loses 4 electrons, oxidation number is +4. Understood? So now we know what is the most electronegative element, carbon. Okay, it is the NCO minus carbon, and this is the second place. So in the given order, electronegativity increases. Understood? Electronegativity increases in the given order. Now, if you go to the answers, you can take this one without drawing much also. So you always have to understand how to do it faster in A levels also, because within 2 hours we have to do 50 MCQs. Okay, 50 MCQs. They are kind of harder than the O-level MCQs. So therefore, it's actually a challenge. Okay, so now when you just scan through the molecules, you will understand the sp3 hybridized one should have the lowest electronegativity. Okay, so therefore you can eliminate the fifth answer. You can eliminate the fifth answer because it is starting from NCO. And then you can say our H2CO is a sp2 hybridized one. So therefore it should have a higher electronegativity than sp3 ones. Okay, so you can eliminate the first one also in that same logic. Then you can eliminate our fourth one also, because H2CO is there between 2 sp carbon atoms. Okay, so sp21 should be lower. So then we eliminated 1, 4, and 3. 1, 4, and 5. Sorry. And then how do we eliminate 1 from the second and third? So you don't have to worry about the last 3, because in the both answers the last 3 are same. Then think about the first 2. Then obviously you can understand if there is a chlorine atom, then it should be more electronegative, isn't it? Because it brings the oxidation number into a more positive value. So that's how you select the answer 3, by a small brief thinking. Okay, but right now my advice is follow the long path. If you know this long path enough, then you can practice the shorter speedy methods. Okay, so don't always try to do everything at first in the speed way. Okay, so take it slowly. Just draw molecules and write things. Then these things will slowly absorb to your brain. Then give some time to process. Okay, give a week or 2. Then after that, when we do such questions in the paper class, you can quickly do that. Okay, so always allow some time for your brain to learn that. Okay, the practice that. I hope now it is 100% clear. Right, and take the fourth question. It is from 2021 A level, and kind of it's a mixed question, so it's a good one to study. So what is the correct statement? So if you select the fourth one, that means you have come a little bit closer, but you haven't seen the last molecule, this one. Okay, so that's why. Okay, good. So anyway, let's learn all the statements and discuss all the statements properly. Okay, Pute? Right, look at the first one. It says electron pair geometry and shape of SF5 are different from each other. SF5 plus. So what do you think? Let's take the first statement. SF5 plus. If you draw the structure, or you can follow that one using my short method. Remember, sulfur is having 6 valence electrons. Okay, so then to bond with fluorine, it is using 5 electrons of that. So then for the plus charge, that means you have to remove another electron. So there are no electrons left. That means no lone pairs. If there are no lone pairs, electron pair geometry is equal to the shape. So no need to draw the molecule also. If you just look for if you just look for the lone pairs around sulfur, you will understand there are no lone pairs. So electron pair geometry and shape are going to be equal. Understood? That's how you are thinking. So just for the understanding, you can draw the molecule also if you want. So SF5 plus is going to be a trigonal bipyramidal molecule. Okay, it's going to be like this. So these 3 fluorine atoms will be in the plane with 120 angle to each other, and the other 2 fluorine atoms are perpendicular to that. Trigonal bipyramidal electron pair geometry and shape. So their electron pair geometries and shapes are equal. So telling that they are not equal is wrong. Understood that? So that's correct. Then look at the next one. Increasing order of the radii of atoms, F minus, so I'll write those things, F minus, then you have Mg2 plus, aluminium, and Cl minus. So in this question today, you don't have to find them in the proper order. You have potassium ions. There are 5 ions and atoms, no? Yeah. So you don't have to find the proper order. If you can find a reason to say this statement is wrong, that will be enough. If you carefully go through these 5 radii arrangement, okay, you will see one clear mistake. Okay, you will see that one at the very first thing. F minus and Mg2 plus. F minus and Mg2 plus. So telling F minus is smaller than Mg2 plus, or telling F minus or Mg2 plus is larger, this is wrong, no? This one is wrong, no? Isn't it? So it's not going to happen. So therefore the whole arrangement you can say wrong. Don't worry about the other things. Okay, Cl minus, argon, aluminum, we don't know them, no? No need to arrange them in the order also. In A level, they are not expecting that too. They just gave this question. It's a very clever one. Okay, they just gave that one. If you to see that if you can figure out this a mistake. Understood? Okay, so F minus should be larger than magnesium 2 plus. So how do we prove that one? What is the theory? Remember isoelectric series? Isoelectric series. Isoelectric, isoelectronic. People are calling this by different names. But anyway, what happens is it is telling you the radii arrangement of ions, anions and cations. So N3 minus, O2 minus, F minus. Then you have sodium plus, magnesium 2 plus, and aluminium 3 plus is the smallest. Understand? Because they are having, they have the same number of electrons, but aluminium, sodium, magnesium, they have more protons, more nuclear attraction. Therefore, their sizes are going to be smaller. Understand? Smaller than the above period anions. Okay? So you can now clearly see F minus is right here, Mg2 plus is here. So it should be smaller. Okay, so in that way, we can say second statement is wrong. Now let's go to the third one. In third one, the number of resonance structures can be drawn for the nitric acid is 4. Nitric acid, HNO3. It's telling the resonance structure. You can draw 4 resonance structures for the HNO3. I think we discussed about HNO3 in our previous discussion also. Anyway, so for HNO3, this is the Lewis structure of HNO3. This is the Lewis structure of HNO3. You should know that. Actually, you are learning that one in another lesson, unit 6. That the structures of acids, right? So nitric acid, it has acidic hydrogen and it is connected to the oxygen. Okay, without that, you don't know the structure, no? I mean the skeleton. So it should be given to you, okay? But in the A-level exam, when you go for the A-levels, you obviously have studied the nitric, so no need the skeleton. Understood? So in this structure, how many resonance structures are there? there are no 4 structures today. There are only, you have 2 resonance structures. Okay. 2 like this, and there will be one more structure having the double bond with the hydrogen connected oxygen. And what do you think, which one is the least stable, or you can say the unstable? You go through these ones, and this is going to be the most unstable structure. Okay, it is unstable and it gives the least contribution. Least contribution to hybrid. Understand? If you just put some random percentages, you can say if this is contributing 40%, this one also contribute 40%, while this is only contributing 20%. Understood? So I remember there was a question earlier paper asking that whether the NO bond lengths are equal. So what do you think? NO bond lengths are not equal. Understand? Because this one contribute a fewer amount. So 2 NO bond lengths will be equal. This one and this one are equal because they have equal contributions. Understand? But the one NO bond length is not equal and it is kind of longer. Okay, this NO bond length is long. Okay, so by anyway, we can say there are no 4 resonance structures. Therefore, the third statement is wrong. Right, now look at the fourth one and let's understand why it is wrong. It says about the carbon-oxygen bond length. Carbon-oxygen bond length. Okay, so they have given you 4 structures. What are they? Carbon monoxide, carbon dioxide, carbonate, and CH3OH. So students are not seeing this CH3OH because it is separated by the word and. That's a kind of a bad thing they did. So we are just focusing on the commas now. Then some students might see only these 3. And when you compare these 3, carbonate is the one with the longest bond length. It is true. But if you consider all 4, actually that's what they're asking now. Then CH3OH is the longest. Understood? So you can see that one clearly if you take the Lewis structure of CH3OH. So therefore carbon-oxygen bond length is longest here. But all others are having kind of multiple bond character. Here you have a triple bond. And here you have true double bonds. And here you have single double in between nature. Remember carbonate? The real structure of carbonate is having partial 5 bonds also. Bond order was 1.33. Understood? So therefore these bonds are kind of shorter. So therefore the fourth one is also wrong. Then obviously fifth one should be correct. And it is about electronegativity. So let's see why that is also correct. Okay. So now you can see if it came for the another exam, it is having a little bit challenge, no? You have to assess 5 statements, no, in order to go to the answer. At least you have to check for the 4 statements. Then you can say at least these 4 are wrong. You can say fifth one is correct. Let's see the molecules. What are they? CH4 and COCl2 and HCN. So you don't have to draw even anything. If you just look at them and think about the arrangement, you will notice that. Here you have a sp hybridized carbon. sp hybridized carbon. And COCl2, you have sp2 hybridized carbon. CH4, you know that the structure, you are having sp3 hybridized carbon. So you can see in this order S percentage increases. Sorry, that means electronegativity increases. So 50% of S character. So that one is correct, no? So if you just scan through the statements, you will notice that fifth one. You will notice that fifth one is correct. Okay. So that's a good question, Lama. Yeah. Go through that one more time. I thought about doing the 2 questions came from 2024 A-level paper. Okay, so now almost we have finished our second unit, and if you go through my tute, you will see that I have added all the structured essays of the previous new syllabus past papers. So in my future classes, I'm going to online classes, I'm going to take one structured essay per day, and I'm going to discuss that one here, because we did only parts of the structured essays in the class. Because when we do hybridization, we only look at that question. When we do resonance, we only took the resonance part and did. Okay, but we didn't do the complete questions now. So in the online class, I'll be discussing complete structured essays. Okay, so we have 5 or 6 structured to discuss. So in the upcoming 6 days, I'll be doing that. Right? And I added these 2 questions from 2024 A-level to our tutor also. You can find them in page 60. Okay, these are the latest questions. So what do you think about the geometry and shape? What is the answer for the geometry and shape? Right, so if you take IO3 plus, so iodine has 7 valence electrons. Out of that, oxygen is usually making double bonds. So you have to leave 2 into 3, 6 electrons to that. And the positive charge is also present on iodine, because oxygen usually don't keep the positive charge now. So it's a more electronegative atom. So it passes the positive charge for iodine. Okay. So then you can see there are no lone pairs left on iodine. So IO3 plus is going to be a structure like this. Okay. If you can't process like this, the speedy method, if it is not ready yet, so just go through the Lewis structure method. Okay. Draw the skeleton, draw 3 iodine atoms around that, and count the electron pairs like that. Follow the usual process. Still, you will end up with the same answer. Okay. But with the time, let's practice how to get this structure faster. Okay, now. Right. So it is going to be trigonal planar. Trigonal plane. So you can go to the answers and see how many answers are having trigonal plane. So like that, let's try to eliminate. So 4 answers are having trigonal plane. You can eliminate the 4th answer. Then go to the next one. If you check the next one, see the answer is trigonal pyramidal. It says trigonal planar. The 3rd answer says T-shape. And the 5th answer says trigonal pyramidal. So if you draw the 2nd molecule, you can eliminate more answers. No? So therefore, let's try to draw the 2nd. Around nitrogen, you have these 2 chlorine atoms. And they are usually forming single bonds. No? So don't try to put double bonds here. Put a lone pair on nitrogen. That is the neutral molecule. So around this one, you have 4 repulsion units. Okay. So 4 VSEPRT units. And then you have 1 lone pair and 3 bond pairs. Okay. So shape is trigonal pyramidal. Electron pair geometry tetrahedral. And shape is trigonal pyramidal. Now you can eliminate 2 answers. 2 answers. You can eliminate the 2nd one and 3rd one. So now the answer is going to be either 1st one or 5th one. Okay. Now if you draw the 3rd structure, then you have your answer, because you have to check whether it is square pyramidal or trigonal bipyramidal. That would be enough. Still, you can get the answer with 3 structures. So chlorine is the central atom. You have 3 fluorine atoms and 2 oxygen atoms. Oxygen is making double bonds, fluorine is making single bonds. So now if you check the electrons around fluorine, 1, 2, 3, 4, 5, 6, 7. So no lone pairs on chlorine. So therefore the electron pair geometry and shape is trigonal bipyramidal. Understood? So what is your answer? Yeah, trigonal bipyramidal. Answer is answer 5. Okay. So if you draw the next one, if F4BRO minus, you will find it as square pyramidal. Square pyramidal comes in with one lone pair and 5 bond pairs. It comes under octahedral geometry. Okay. So that's clear, right? Right. Let's do the sixth one now. That's also a similar question to one they gave in 2021. So what's the answer you selected for the sixth one? First one, among the species NCl3, SO3 and PCl5, only polar species is NCl3. That is correct. Okay. So what are the molecules? NCl3, SO3 and PCl5. So what is this polar non-polar thing? In our last week, actually we learned that. If you draw NCl3, you have a lone pair. So I said to you that if you have nitrogen chlorine together, chlorine is more electronegative. Understand? So then since the repulsion units are not cancelling, the dipole moments are not cancelling, this is going to be the resultant dipole moment is mu r is not going to be 0. Therefore, this will be polar. But if you take other molecules like SO3, see it's a trigonal plane, dipole moments are cancelled. And PCl5 also dipole moments are cancelled. Dipole moments are cancelled. Understood? So both those two molecules are going to be non-polar, while your NCl3 is polar. So that's a good statement, no? So you have given some answers. We'll see whether they are correct, okay? Look at the second one. Again, the ionization energy. Lowest ionization energy is shown by aluminium. That is also correct. Those are third period elements. First ionization energy, you have this zigzag variation. Magnesium, aluminium. Then you have silicon and phosphorus. This is the order. So as you can see, aluminium is having the lowest first ionization energy. Why? Because magnesium, you can explain why magnesium was higher, no? It is 3s2 stable. That's why we are having a higher ionization energy for the magnesium. What we know is usually when the radius is higher, ionization energy should be lower. Okay, so magnesium is having a higher radius than aluminium. Okay, but still removing electrons from magnesium is difficult. Why? Because it is having this stable 3s2 configuration. Understood, Lama? That's why magnesium is having a higher ionization energy. So just draw the zigzag and place them, you will understand. Then go to the third one. Go to the third. Carbon and oxygen. Lowest negative value for the electron gain energy is shown by carbon. Lowest negative value. No. Why? Because if you take EG1 positive, that means those who doesn't like to take the electron are group 2, group 18 and nitrogen. All others are having negative values now. So your boron, carbon, oxygen, they all have negative values. That means they like to gain electron. Okay. So then you need to think which like the most. That's the thing. So boron is basically is a metalloid. Okay, carbon carbon is a nonmetal. Oxygen is also a nonmetal, but oxygen should more likely towards the electrons because it is having a lower radius. Radius is not the only factor, okay? So there are electron configurations and everything affecting this, right? But when you compare these three, you can say oxygen is having lower radius, therefore more nuclear attraction. You can see it is having more nuclear attraction. Understood, Lama? So we can say oxygen, what did we say? Is it telling oxygen is most negative? No, it is telling carbon is more electron. So electron gain energy. So no, it's wrong. So that must be our answer. But anyway, let's see the fourth and fifth statements to confirm our answer. Okay. So look at the fourth one. Chemical species NO3 minus SO3 and SO3. Yeah, there are four. NO3 minus this one. Trigonal plane. SO3 also trigonal plane. So they are having equal shapes. Trigonal plane. Take this one SO3 2 minus. You have a lone pair. So pyramidal. And ClF3. ClF3. You have two lone pairs. So this is having T shape, no? Yeah, that is correct. This is pyramid, trigonal pyramid. T shape. So only these two are having the same shape. So that is a correct statement. Not going to be the answer. Look at the last one. Good question, you can see. Among the ions, lithium, sodium, beryllium and magnesium, largest difference in size. This was given in 2022 or 21 A level also. The same, similar, very similar statement. So it's very important to do past papers repeatedly, okay? Largest difference in the size is between sodium plus and beryllium 2 plus. So let's write them. Lithium plus, sodium plus, beryllium 2 plus, and magnesium 2 plus. So the largest difference is between sodium plus and beryllium. So now these ions, Lamai, it's kind of reminding us a previous theory. Remember, we have these four ions you can find in the adjacent four boxes. Lithium, beryllium, sodium, and magnesium. This is how they are arranged in the periodic table. Group 1, group 2, first, second period, then third period. Okay, and they are ions. You can think the variation using the zigzag, our mirrored effect. Remember, in first few paper classes, we discussed this. This is how they are arranged. Okay, so now you can see sodium plus is largest, and then magnesium 2 plus. Then you have lithium plus, and the smallest one will be beryllium 2 plus. Okay, so the largest difference will be there between beryllium and sodium ions. Let's see what the statement is telling. Yeah, beryllium and sodium. So that means fifth one is also correct. Then that confirms our answer is the third one. Isn't it? So you might not have a clear idea regarding the negativity, negative value. Okay, but you can see other statements are correct now. So let's stick to the third one. I hope the six questions we discussed today, you had a good understanding. They're all about the second unit. Very few things are there about the first unit also. So study and go through the questions again and write reviews for these questions and attach them in the bonding theory tutor. Okay, Lama? So good night, everyone. Study well.